Hello, we're now getting into some advanced topics. In this video we'll tackle how to provide other types of values to our shader. Usually you would like to pass in some transformation values for the model that you're rendering. This is because the Vulkan space is from -1 to 1 on the x and y axis, and you might want to specify coordinates that are in some virtual scale. For example, imagine you render 3D objects triangles. Each triangle might have coordinates which correspond to a real-world scale, where, for example, the top of our triangle might be 2 meters high. You would like to capture this entire 2 meters high triangle in Vulkan, as if it's seen by a real-world camera or human eyes. If you provide vertices in your scale though, they would be outside of this -1 to 1 range. This is where matrix transformations come into place. You would like to tell the GPU to take all these vertices and transform each vertex by multiplying it by a transformation matrix. The matrix is not part of the object itself. To simulate a 3D camera, we usually have three matrices that are combined together. The first matrix modifies the specific object position, rotation, or scale in the world. You might be drawing a few cubes using the same vertex buffer, but you want each cube to occupy a different position in space. Then you have a view matrix. This matrix is used to move all the objects relevant to the viewer. The viewer is also known as the camera. Since the viewer is just a concept, if a viewer is looking south, what you do is that you transform all the objects with that viewer information. That way, the ones that are considered south should end up in the front of the viewer. And finally, you multiply all the objects in the view by something called a projection matrix. The projection matrix job is to bring all the visible objects based on some scale into the Vulkan's -1 to 1 scale. Even though you can transform vertices on the CPU, this is a better job for the GPU. Transforming the vertices is a task of the vertex shader. And before we can transform anything, we need to be able to pass those three matrices to the shader. In this video, we will be passing the model matrix. This is the one that will be specific for each object. To do this, I add a new public function in the graphics object called setModelMatrix that takes a mat4 struct. As always, we will take the signature and move it into the CPP file. And let's also create a body for it. In the implementation file, then I will record a new command called command pushConstant. We have to pass in the command buffer, pipeline layout, shader stage, offset, size, and others of the values. The push constants are part of the graphics pipeline layout. So here at the graphics pipeline creation, we previously created an empty layout. Now to this layout, we will add some push constants range. I need to create a new VK push constant range object I call model matrix range. And we need to set the matrix range offset to 0. And let's not forget to initialize it. And it will have the size of a single matrix. Each GPU supports a limited size for push constants, but there is a minimum that all GPUs must cover. And this minimum will cover at least one matrix. We set the stage flag to the vertex shader only. And we will pass that range to the layout information. Now, push constants can be read in the vertex shader. We need this syntax here that we will be taking a push constant layout, and it will consist of an uniform model struct called model. And this struct will contain a single mat4 called transformation. In the shader's main function, when we set the geo position, we'll then multiply the input position with this matrix. And going to the main file now, we can create a new matrix. This matrix will be a rotation matrix. We take an identity and rotate it by 19 degrees. And we set the y-axis for the rotation. Actually, the z-axis for rotation. The z is the depth one, or going into the screen. To use the dose matrix function, we need to add this include to the matrix transformation header. Now we can call this setModelMatrix function before our draw call. And if we run this project, we can now get a triangle rotated by 90 degrees. If we render a second triangle though, it will still be rotated by the same degrees, so we will not see anything different when we run it. So what I will do is set an identity matrix after each draw call to reset this push constant. I will then build this, and now we get two triangles, one over the other. One transformed by a rotation and one not. And finally, we need to also consider the case when a model matrix hasn't been set. You see, push constants are mandatory for rendering. Vulkan will not provide the default value for us. So we have to have at least one call in the begin frame where we set the model matrix to an identity. Now we can run this and see how we switch the triangles overlap. Well, this is it, and I will now clear this second triangle code. You can play around and see what other transformations you can apply and set them as a push constant.